Welcome to VegNet. These are a series of podcasts on commercial vegetable production from the Ohio State University Vegetable Crops team. Today we're going to continue our discussion on pumpkin production, and in part 2 we will discuss weeds, insects, and important diseases of pumpkins. Weed control in pumpkins is relatively difficult compared to other vegetable crops, and one must think about many ways to control weeds. So we'll talk a little bit about chemical weed control, mechanical weed control, and also cover crops and living mulches. We are first going to look at some chemical weed control options before planting. This is the best time to control emerged problem and perennial weeds. Herbicides such as Gramoxone Extra or Roundup can be applied before or after seeding, but before the crop emerges. Any weeds that are present will be killed. Next, we will look at some pre-emergence options. These are applied after planting to the surface of the soil, but before the crop emerges. Strategy is a premix of Command 3-ME and Curbit. Rainfall or irrigation is required to activate this herbicide. Sandia is also a pre-emergence herbicide. If it is accompanied by heavy rainfall or cool, wet weather following the application during the germination and early growth period, this may result in severe crop injury and/or reduced stands. Dual is newly labeled for pumpkins, and it controls grasses and pigweed. The Command 4EC formulation is no longer available for pumpkins, but growers should be aware of problems with Command spray or drift that may injure sensitive crops. Usually the label has distance requirements from other horticultural enterprises, and a grower should look at the label. In the picture on the right, you can see an example of Command injury on pumpkins from too high a rate. The crop, however, will grow out of this, and there will be little adverse effect on the pumpkin crop. One should be aware of residues when using Command because this may limit subsequent crops. Cropping limitations vary depending on the rate applied, so read the label. The above picture shows Command injuries on tomatoes. Pumpkins were in this field the previous year, but the lack of 14 inches of rain the previous year resulted in Command residues causing tomato injury the following year. Some post-emergence herbicide options for pumpkin growers are Sandia. You should wait until the crop has reached the 2 to 5 true leaf stage but before flowering. You probably will see some temporary yellowing or stunting, but this should be not significant and not affect final yield. The herbicide Post is also available for post-emergence control of annual and certain perennial grasses. Avoid application during periods of high temperature and humidity, such as temperatures above 90 degrees Fahrenheit and humidity above 60%. There is a 14-day PHI interval. Another post-emergence option is direct shielded application of such herbicides as Gramoxone and Roundup for weeds between the rows. Next, we want to talk about why should we use cover crops. This work comes to us from Dr. Andy Wyanott, plant pathologist who is now at Rutgers University. First of all, cover crops add organic matter back to the soil. They reduce soil erosion, help control weeds, and conserve soil moisture. They control soil-borne disease. They also increase fruit cleanliness and quality at harvest, but they are not without their disadvantages. Here's an example of some fall-sown cover crops. Winter rye combined with hairy vetch still work the best. Notice the nice thick biomass layer that's present the following spring. Here we can see herbicide-killed spring oats on the left versus spring rye on the right at pumpkin seedling emergence. Note the differences in the amounts of biomass. Spring-sowed oats will last much longer into the growing season, whereas spring-sowed rye will break down and disappear in just a few weeks after herbicide kill by glyphosate or Roundup. Excellent early weed control in both, however much better in the spring oats later in the growing season. Here's a close-up view at emergence and what it looks like later in the season. This slide shows the various mulching systems that Andy looked at, from living mulches, the green part in the back of this picture, to killed mulches and rolled over in the middle, and plastic mulches up front in the foreground of this picture. Next, we move into insects, and a key pest are the cucumber beetles, both the spotted on the left and the striped on the right. These beetles cause two types of damage. One is severe physical damage to young seedlings in the cotyledon leaves, and also they transmit and infect young plants with bacterial wilt. Here's an example of pumpkin cotyledons with heavy feeding damage from cucumber beetles. Cotyledons are very important to vine crops, and any type of damage affects subsequent crop growth. As we said before, cucumber beetles transmit bacterial wilt disease. They're thought to be less of a problem after the crop is established, except in 1998. Near harvest, they start to feed on the fruit, making it unmarketable because of all the scarring they cause. Control is achieved by using a systemic insecticide like Admire at planting, or a insecticide like 7XLR, which is safe for bees, every 5 to 7 days, when 3 beetles are found per plant. This picture shows a pumpkin seedling surrounded by striped cucumber beetles that died from Admire applied in the seed furrow at planting. These are the early symptoms of bacterial wilt in pumpkins that is caused by cucumber beetles. Notice the wilted appearance and death of the young leaves on the left. Older leaves exhibit necrosis or death between the main veins of the leaf. In the picture on the top right, notice the vascular tissue at the base of the stem has turned brown, indicating bacterial wilt infection. Now you are looking at bacterial wilt symptoms at an advanced stage, just as the plants start to flower or begin to set fruit. Eventually, the whole plant begins to wilt and die because bacteria clog up the xylem tissue. Losses in the field can amount from anywhere from 25 to 40% of plant stand. When you look in and around pumpkin vines, especially in their flowers, you will see a lot of corn rootworms. The western and northern corn rootworm do not transmit bacterial wilt. Western corn rootworms are often seen working the flowers, as we mentioned before. Notice the center stripe on the western corn rootworm does not go all the way to the end of the body like it does in the striped cucumber beetle. The southern corn rootworm is the same as the spotted cucumber beetle, and it does transmit bacterial wilt. All 3 of these beetles will feed on pumpkin fruit rind. Here's an example of what cucumber beetles and corn rootworm beetles can do to young green fruit just turning orange. This is an example of the damage they can do to ripe fruit, and this can happen in as little as 2 days. Growers should scout their fields frequently late in the season, especially after light frosts, to prevent rind damage to pumpkins. Cuc beetles can also feed on pumpkin handles, and is severe enough they can make the pumpkins unmarketable. The next important pest of pumpkins are aphids, and there are many types that feed by sucking sap from cucurbit leaves. Aphids transmit several viruses to pumpkins, including cucumber mosaic, squash mosaic, papaya ring spot, zucchini yellow's mosaic virus, and watermelon mosaic virus. During a 3-year field survey, the predominant virus in Ohio was found to be watermelon mosaic virus, also known as WMV. Typical leaf symptoms are a mottled green-yellow color with a bubbly leaf texture. Some leaves actually appear as if they've been hit by a phenoxy-type herbicide. If virus comes in early enough, it can limit fruit set and yield. When it comes in late, it makes the fruit bumpy and potentially unmarketable. Infected fruits become bumpy, discolored, and display a weird mosaic pattern, which is not appealing to most markets. So what are some control strategies for virus management? Well, reflective mulches are effective in repelling aphids, but vines quickly cover the mulch, resulting in no significant reduction of aphids by midsummer, thus no reduction of virus in infected fruit. Predators have not been effective in reducing aphids, and in Ohio trials, stylet oils and chemical sprays have not been successful. Basically, we're going to have to rely on genetic resistance to virus. We have observed some genetic resistance to WMV in transgenic experimental cultivars, but companies are reluctant to bring transgenic lines to market because of the current controversy. Notice the vines in the bottom of this picture compared to the vine in the top of the picture showing virus symptoms. Another insect which can become an important pest at times is the squash vine borer. First symptoms are shown in the leaves when they develop a widespread interveinal yellowing. Plants eventually will wilt, but not as fast as they wilt with bacterial wilt. Next we move into diseases. Anthracnose and powdery mildew commonly occur on pumpkins. Downy mildew, Phytophthora blight, and white speck are less frequently found, but important diseases. A key disease in pumpkins is powdery mildew. It usually starts without fail the last week of July. You will first notice small white powdery spots on the upper surface of the leaf, but this also can occur on the lower surface. Notice the picture on the left. Soon these spots quickly coalesce and eventually cover the entire leaf. Notice the picture on the right. In the above picture, notice unsprayed vines are in the back and sprayed plots are in the foreground. Mildew quickly covers the vines and the leaves dry up and die. Mildew also affects fruit handles in the center picture and can injure the handle. Right, notice the yellow areas. These are points of entry for secondary infection that lead to soft handles or ones that turn brown. To control powdery mildew, treat with fungicides as recommended in the Ohio Vegetable Production Guide. You also might remember that in part 1 of this discussion, we talked about the importance of selecting varieties that have good powdery mildew resistance. Another fungus disease that can cause pumpkin handle problems is sclerotinia stem rot. If you look in the handle, you will find small round structures that make the stems become very soft and stringy and easily break away. In advanced stages, the disease enters the fruit and begins to rot out the center. Some have suggested that you could sell the pumpkin as a pre-carved pumpkin, but they are kind of juicy and leak a little bit. The best control is crop rotation and sanitation. Phytophthora blight is a disease that usually occurs after very heavy rains or flooded fields or after heavy thunderstorms. It usually occurs during periods of high temperature and very high humidity. Vines quickly collapse after about 4 to 8 hours. The disease can also be seen on fruit as bright white mold covering portions of the fruit. Fusarium belly rot is another soil fungus disease, usually occurring during wet years. The fruit actually stick to the soil because of the fungal growth between the fruit and the soil. If the field has had a history of Fusarium belly rot, anthracnose, or gummy stem blight, treat with Bravo or other recommended fungicides at vine tip and every 7 to 10 days until harvest. Also practice at least a 3-year rotation. Microdochium blight, or correctly known today as Plectosporium blight, or going by the common name white speck, is a fungal disease that attacks pumpkins during summers of very humid, rainy weather. The disease is identified by the diamond-shaped white spots or specks that cover the fruit and the stems, making it not marketable. No control really exists, but the fungicide Manzate has been shown to be effective in controlling this disease to a certain extent. Downy mildew has become an important disease over the last few years, showing up in late July or early August. Typical symptoms show leaves that cup upwards with a brown burnt appearance. This disease wipes out the foliage very quickly, but is really not an important fruit disease. However, with foliage gone, fruit set will be affected, or fruit that are present will be sunburned. Combine a strobilurin fungicide with a protectant fungicide like Bravo. Watch your frac numbers and do proper rotations with your different fungicides. Other problems you might see with your pumpkins are birds poking holes in the skin, mice chewing on the rind, or even an occasional hailstorm damaging young, immature green fruit. If late August or early September is very hot with temperatures in the 90s, you may see sun scald on pumpkins. This starts out as a dark red area on the surface of the fruit. The area becomes sunken and soon starts to spread. The area begins to spread over the fruit and becomes very soft, and really soon secondary infection will come and cause rotting of the fruit. You may want to harvest pumpkins early and store them to prevent sun scald. Harvest pumpkin fruit when they are mature, avoiding cuts and bruises. Cure after harvest at 80 to 85 degrees and 75 to 80% relative humidity for a period of about 10 to 20 days. After curing, store them at 50 to 60 degrees and 70% relative humidity. The curing process can be done out in the field unless it is very wet and rainy. The key point to storing pumpkins is to keep the fruit dry and provide very good air circulation. Temperatures below 40 degrees for long periods of time will cause chilling injury and lead to fruit rots. Pumpkins will keep 2 to 3 months if properly handled. Well, what about my green fruit? Well, fruit with 40 to 50% orange color will ripen normally. Full-size mature fruit that are 90% green will ripen, but this will be dependent on temperature. The colder it is, the longer it will take. Immature fruit that have the bright, shiny green color will probably not ripen, even at warm temperatures. Well, if it's past Halloween, what do I do with my leftover pumpkin fruit? Well, try making Christmas decorations out of them and see how many you can sell. Well, this concludes the two-part series on pumpkin production. Check out our website to see what else is going on in commercial vegetable production at Ohio State University.